All right. Hi, everybody. I'm Therox, and this is how the compiler compiles. To hit 25 minutes, I'm going to go hella fast. So this is me. I'm on GitHub. I'm a compiler team member at Microsoft. I've been doing it for about 2 years. You might have seen the new handbook, the new website, or some of the definitely type contribution flows. Outside of that, I've done a lot of open source the last decade or so, ranging from dependency managers to sort of build tool CI things, to Shiki's 2slash, which takes a lot of the sort of processing of code samples that we use in the TypeScript handbook and website and sort of makes it available for everyone to use. But for this, we're going to be talking a lot about the TypeScript code base. So if you've not seen it, that's available on Microsoft/TypeScript. And the programming language itself is built in TypeScript. It's self-hosted. It's been around for a while and has about 250,000 lines of code in just the bit that is sort of shipped to people. Outside of that, there's a lot of sort of infrastructure code and testing and stuff like that. There's about 80,000 test files in there. Most of how TypeScript is tested is via sort of integration-like tests, where it checks the entire state of a compile, sort of before and after, if you will. There's about 5,500 different files in the compiler, though realistically there's like 8 that super count, and the rest are all just sort of useful for their own scope. It generates about 500 notification emails a week, so that's about 70 a day if you're watching. The idea of TypeScript is about 11 years old, and in that process it's gone through about 2.5 rewrites. There was one in F#, one in C++, and there was a full rewrite after TypeScript 1.1 was released. And for this talk, the target audience is sort of anybody that's kind of interested in either contributing to the TypeScript repo, sure, but maybe you're kind of interested in understanding what's going on under the hood in the compiler and just are curious about what's going on there. I expect a level of technical competency. Like ideally you should know what set is or what map is in JavaScript, and you should have a general sense when to use them. If that's you, then you definitely know enough to be able to understand pretty much everything inside this talk. If that's not you, there might be stuff that goes over your head, and that's just okay. You can come back to it later if you're interested. I built this talk to complement another talk, strange enough. Anders gave this great talk back in 2015 that talks about like the mental shift that he had to make in making and designing and architecting a system like the TypeScript compiler, where instead of going from sort of a pipeline of I have some files and I have some files, like modern compilers take the responsibility of also integrating with the editor, and that like changes the pipelining process quite a lot. And so in this talk, Anders really digs into the details of how and why that has affected it. And I don't actually go too deeply into those details because that is such a good resource. So I'd recommend sort of this and that talk too. So to give you a sense of what we're going to cover, we're going to be going over these 3 major topics, and then there's a little extra at the end. We want to sort of understand the sort of whole pipeline that goes on inside the compiler, and these are the 3 main sort of responsibilities that go on. So to give you a sense of what the entire pipeline looks like for TypeScript, this is a document. This is a diagram I made for documenting TypeScript. And we're going to be focusing on first on the sort of tokenize and parsing. Then next we'll be looking at binding and type checking. And then we'll be moving on to transform and emit in order to sort of get a better sense of what all those pieces do. So to get started, converting your source code to data. So we're gonna look with this bit of sample code. It creates a constant, it calls a function with that constant, and it defines a function underneath. And the way that sort of JavaScript language works is that there are statements, and a statement is effectively sort of a chunk of executable code, usually finished with a semicolon. So a statement is something that runs and then ends, and then the next thing that happens after that. So in this code, because there are three separate statements. There is one that first sets up this variable called MSG. Then there is a function call that uses that MSG, and then there is the definition of a function. So one way to sort of think about how that could be mapped into your head is that there is a source file, and inside that source file there are three statements. And that's a pretty good, it's actually very accurate to how TypeScript thinks about it and how most JavaScript engines work. We want to dig a little bit deeper, so like let's dive into that first statement. And realistically, the next sort of thing is that we need to think about this recursively. So, you know, there's also sort of sub statements inside that statement, and you know, we could think of those as sort of tokens inside that statement. And so you end up building a sort of tree of the syntax that you find when you're looking through some code, sort of in this kind of shape. And so almost every language has something like this called a syntax tree. Sometimes you'll hear the term an abstract syntax tree or a concrete syntax tree. When I brought it up with the TypeScript team, they were just like, yeah, those are labels that don't necessarily apply too much anymore. So if you hear abstract syntax tree, it's more or less the exact same as syntax tree, and so is a concrete syntax tree. The difference is like something that was important a very long time ago, and it's not very important anymore. So if I accidentally call it an abstract syntax tree, not a problem. So to create TypeScript syntax tree, we mainly use two objects. We use a scanner and a parser. So let's go through both of those. The scanner is a, it's a TypeScript file, like a lot of these things are going to be, and it's about 2,500 lines of code, but it has quite a very simple, easy to understand responsibility. It takes some strings and it turns that into a set of tokens. So you could think of it as it's something that starts from the left and works its way right, and when it hits a space, for example, in this case, it says, hey, I've got a const. Okay, so I know that const actually refers to a constant, like sort of, you know, a variable declaration. It's start, and so I will say, hey, I've just found a const, and then it continues on. It finds an identifier, and then it finds a colon, and so on and so on. And the scanner itself doesn't really think much about it. Its entire job here is to just go from left to right, finding chunks of text and just saying, hey, this is what I think I found. There are multiple types of contexts within which a scanner could be used, so like a JSX, JSDoc, inside a regular expression. But realistically, its main goal is start from the left, go right. When you see some sort of white space-y thing, just, you know, pipe up something that you think, pipe up a token that you think is important there. And, you know, while I was sort of digging around in the scanner to understand how this all works, I ended up building a TypeScript playground plugin called the TS Scanner, that its job is just to take whatever arbitrary code you can put in the playground, and it will just tell you what the scanner results are. And this is kind of fun to sort of understand how a system like that works, but it's just available for you to, you know, dig in. Every single part of the TypeScript pipeline has a way of sort of emitting a diagnostic, and a diagnostic is effectively TypeScript's way to describe an error or maybe like some helpful hint. And so the scanner has ways of being able to raise errors in your projects. So in this case, a lot of the errors here are sort of very simple, this sort of JavaScript is just never allowed kind of thing. So like, you know, you can never run a JavaScript file realistically if the quotes never ends. I mean, I guess you could, but it would not probably do what you want. And you know, it's illegal for having two underscores inside a number, and that would cause a runtime error straight away. And so the scanner can understand a lot of these sort of simple rules and will raise them up whenever it sees them. So I said there was two objects here. The other one is the parser, and the parser is a bit more of a chunky class. No classes inside the TypeScript code base. Probably no classes. I bet there's one or two in that 500 files. You know, it's 9,000 lines of code, so it's starting to do some work. And its responsibility is to actually understand the tokens that are given to it by a scanner and to sort of turn that into a tree. Now, when you look at some of this sort of code, right, like the first token that it receives from the scanner is a const, and what the parser knows here is that in order to start a sort of a declaration of a variable, it actually first has to create a variable statement, a variable declaration list, and then it can add the variable declaration. And then from there, it sort of takes the next identifier, which is an MSG, and then it sees a colon, which means that, you know, the next thing is not going to be a new sort of syntax node. It's actually going to be attached to this existing one, and that's where the string gets in, as well as the assignment that happens afterwards. And so the parser, it understands the context within which the scanner is running, and that's sort of its job, is to just sort of keep scanning through the document, but understand the context within which it's scanning, and that gives it the chance to sort of build up this syntax tree, which is then used everywhere inside the TypeScript codebase. So a syntax tree has a few different ways that you can see them, also visualize them, because they're all sort of in-memory things. There's the AST Explorer, which is a sort of general purpose AST Explorer. It works with many different languages and many different tools. This is super solid. This is what I first used to use before I switched to TypeScript. There's the TypeScript Playground, which has an AST viewer inside it. If you go and turn that on in the settings, this is pretty solid. It's not the greatest. I could probably do with putting some more time and effort into it at some point. But it does a good job, and for us as compiler developers, it's very useful because it also will work on like pull request builds of TypeScript and nightly builds and stuff like that. And then there's the TypeScript AST viewer, which realistically is kind of the best one if you're working on sort of the compiler and understanding and real details about what's going on inside the system. It's a very well designed website that's nearly always up to date. David does a great job with this. Good work. So those are 3 different ways in which you can see the entire tree of almost any file. And this is a good way to get some insight into what your code is turning into in the end. So sometimes this can be a good way to find out that, you know, if there's a bug in TypeScript, like this is a good way to find that out. The parser gives different types of errors than the scanner does. The parser gives sort of scanner-like errors, but ones that require understanding that it's doing it in the wrong place. So if the scanner says, hey, I've just got a private identifier, like that new thing that was added to classes last year, I think, and it's not inside a class, then the parser knows that it's not inside a class, whereas the scanner doesn't necessarily have that context. And so those are the sort of error messages that you end up finding inside the parser. So that's the parser and the scanner. That's basically the way in which text is turned into sort of a useful data structure inside the compiler. From there, then, you know, you have to ask yourself, how does type checking work then? And that's pretty complicated. So the type, where we care about these 2 steps. There's this binding step, and then there's this type check step. So we'll start first with the binder, and then we'll work our way on. So the binder is one of those things that I thought was very, very complicated to describe. You know, I've iterated on this a bunch of times, but eventually just discovered that it's actually much easier to not think of it as a single thing, but to think of it as many things done at the same time, because that saves on speed. So to describe that, I took a page from the TypeScript website. It has about 250 lines of code, and that actually turns into about 2,500 syntax nodes. And that's just like one page in a lot of pages in the TypeScript website. And so what happens is that the TypeScript compiler needs to convert every single file, every single JavaScript TypeScript-y file that it thinks is important, and convert that into a source code, a syntax tree like we saw earlier. And so what ended up happening is, in order to reduce the amount of times that we have to look over the entire tree, like TypeScript has a concept called the binder, and the binder is just basically everything it can think of jammed into a single run of of going through the entire syntax tree. And so it effectively has four major responsibilities. It is to create symbol tables, which is basically a way of saying like knowing where a thing is in scope. So if you click on go to definition on something, where actually is that definition? And it sort of keeps track of which scope you're in over time, in order to give you like the tooling support that you would like, and so that TypeScript can keep track of where an identifier is in different places too. It sets up the parent on all of the syntax nodes because that's not done on the way while it's being created by the scanner and parser. And it creates the flow nodes. It was so tempting to like include a really big complicated section describing how flow nodes work. It's really technically very interesting. And it validates, oh, that's used for narrowing, as it says on the screen. And the binder has the ability now, after a full syntax tree has been made, to be able to know whether the JavaScript file is a script or a module. Prior to having the full tree, we can't issue errors related to either of those two types of things until we know what type of file it is. And so that's how the sort of diagnostics that you see from the binder tend to be related either to this thing exists twice, or this thing only runs in strict mode. And strict mode is something that you can opt into in a script, but that every module is in strict mode. And so the binder is a pretty easy concept to get your head around once you think, it's only going through the tree once for performance, and it has a bunch of different responsibilities all just sort of jammed into a generic class called binder. Okay, so the checker checks, hey, and it's too big to show on GitHub, so here's my editor showing the same thing. It's about 42,000 lines of code, which realistically could be a talk or two on its own. And we're only going to do the high level overview of this because we've got 8 more minutes. And to some extent though, I don't feel too guilty about not diving the super deepest into this, in part because most people's talks about like intros to TypeScript or advanced TypeScript theory, all of those are truly about how the checker works and how the structural type system works, and like people do a really good job at describing that, so it doesn't need to necessarily be in here too much, but the interesting parts about how it's architected are relevant to this talk. So what's interesting first for me was trying to figure out like how much of the sort of diagnostics that come out of TypeScript come from the checker, and it looks like the vast majority. The checker definitely dwarfs everything else, and it's it's in its name, and these are conceptually checks, so it's doing some great work. And it has two main things that I want to focus on, which is how it checks structurally and how it compares types. So thinking about the checker, the structure of how it is architected is to echo the structure of how a syntax tree is architected inside TypeScript. So looking at this comparison of the assignment that happened on the first statement of that source code, we first look at a source file, and then we go into a variable statement, and then a variable declaration list, and a variable declaration, and so on and so on. And those map directly to the names of the syntax nodes in that syntax tree. And then eventually, nearly all sort of checks find their way to a function called isTypeRelated to. So in this case, we're comparing like every possible string to a specific string, and so we're asking like, can this one string actually make its way into the sort of global string type, if you will? And in this case, it actually hits a sort of shortcut that we have, which is a isSimple type related to function. And I thought this was kind of interesting because what ends up happening is that we pull out these types and look at them, but the things that we look at in TypeScript are actually these flags, and these flags are sort of they play to the idea of just how dynamic JavaScript is under the hood. That like something could be string like, something could be boolean like, something could be function like. All those are like ways in which the types that exist at runtime can be sort of hand wavy. In this case, what we're seeing is basically a string like being applied to a string, and that ends up passing in this case. To think about it in a little bit more complicated example than two strings, if you compared this object to this other object, first what TypeScript would do is it would look at these two outer, the type of the outer object. And in this case, it's going to have an object-like flag and another object-like flag, which means it would say, yeah, they're the same. And then what it will start to do is it will go through every matching property in the target and check to see if there is a, if the matching property is assignable, because TypeScript is a structural type system. So it cares about each individual part being comparable, being assignable to the other. So we're going to now go inside. It's going to look, hey, does this property exist? Hello? And it does. And then it's going to look now at the value of the property, which in the type in this case, which is the type number versus the string world. And that's going to fail. And that's realistically like the sort of high-level structural overview of how it thinks about this stuff. To dive into it deeper, I would strongly recommending that you actually just, you can't do this in the playground because it's just not a very good experience. Download the compiler and you make a test file that just is the source code you're interested in, and then just put a debugger in some of those functions that I mentioned earlier, like in that syntax tree. And you can click around really quickly, and you really get used to exploring the compiler this way. All right, let's look at creating files. So we have the emitter. That's like the main object that's responsible for taking files and sort of taking syntax trees and turning that back into a file. It sort of handles a few different things, but like figuring out what type of things to emit. Should it be a DTS file? Should it be map files? Should it be bundled? And it sort of keeps track of what temporary variables are used inside a file, so that they don't clash. And this file actually hosts a thing called the printer, which takes up the majority of the source code in that in the file. And really, all that's doing is being, it's taking a syntax node and it's converting that into text by understanding what the node is on each one. And then there's the transformers, which I think are very interesting, and so we're going to go into that in a bit more detail. The transformers are a syntax tree to a syntax tree transformer. So in this case, this is effectively what happens in the TypeScript transformer. It removes the string in the type during the transform. So it looks to see a variable declaration, and if a variable declaration has a type, then it will just null it out. And that means then later when a printer hits these nodes, it will see, oh, there's no type in there, so I'm not going to actually do any work and try and turn that into a string. The way that it works overall is that there are many different transformers, and this is the longest possible transformer chain you can get. And that's if you have the default settings in your TS-config, and this is what it would look like if, say, you had set 2017 as your target. It basically will sort of it'll take your syntax tree all the way through these transforms until it hits the end, and then once it hits the end, it passes it off to a printer, and that printer will then turn that into text. You can get a better understanding of how the transformers work by using this playground plugin, the Transformer Timeline. It's really useful, really good way to sort of dig in. And I thought it was interesting to sort of dig into how all these pieces come together. So, that diagram we saw at the beginning, well, actually that's based on the program. The program is sort of the coordinating concept that happens inside TypeScript. It's like the first thing you would create if you're using the TypeScript compiler API, as we'll see. So this was that diagram. Like it is the responsibility of the program to do all of these. That's where it came from originally. And so to give you a sense of what I mean by this is what it would look like in the compiler API, like this code basically will go through the three major phases that we talked about in three separate lines. Whether you need all of them and how you use them, it can differ, but like at the end of the day, those are all available for you to be able to use as part of the compiler API. And so if you want to dig into the compiler API, there's the TypeScript repos wiki contains nearly all that information. And I'd strongly recommend having a play. We have a channel on the TypeScript community Discord devoted to people using the compiler API and sort of asking questions about how it all works. And that was me. That was an overview of the TypeScript compiler at a high level. We went through many different parts of the system, trying to understand like why they were created and how they work and how they sort of act as a pipeline altogether, and how they sort of integrate by first going from text to syntax tree, then syntax tree to syntax tree, then syntax tree to text. And that's kind of the whole pipeline. So thank you, everyone. Have a good day, and see you later.